Okay, guys. So good evening and welcome back, everyone. So we are going to continue today our Linux session, that is Linux Day-8 session. And today the date is 26th of your July, and the timing is 9 p.m. IST. So yeah. Okay, guys. So in day 7, right, we had discussed about something on what exactly an inode, right? On the day 7, we discussed about the inode, which was very important. Discussed on inode, right? And discussed on the hard link and soft link, right? If you remember, hard link versus soft link, right? So these are some of the things which we discussed. And also we discussed some of the few of the commands, and we also like we also discussed on like what are the other things which we have to learn in our upcoming session. So we got a picture like we have to learn a lot of commands. We have to learn about the shell and shell features, and many things we have to learn, right? And yesterday, like we like in the 7 types of file, I just stopped with the hard link and the soft link, right? This is what we had stopped at. So today, what we're going to do in today's agenda, we have to continue with our commands. Continue with the commands. We will also learn about the V editor, which is important, and we will learn about how to write the shell script, our first shell script. Before that, how to write our first program. Suppose if I say cut C language program, how to write a C program, how to compile, and how to execute it, we'll see that. It's a small exercise which we'll see. And then we will discuss about what is the difference between the interpreter and a compiler, and right, and also like what are shell features, right? So many things are there which we need to cover today, right? All those things we will see today. Okay. Now, so yesterday we learned about the difference between hard link and soft link, and we already discussed it. So if you have any doubts, you let me know, or else we will go ahead. Or if you still have any doubts, like we can park aside, and or at the end of the class we can have a discussion, right? So guys, one more thing, like I know like some of the sessions like it takes more than 1.5 hours. We will get involved in doing a lot of discussion. I got some feedback from some of you that some of the things which we are discussing, it is tangentially going like we are too much discussing. So what we can do, that like we will stick to our agenda, whatever we have a day-to-day agenda, and then at the end, after 1.5 hour class, so we can have a discussion on any other thing what is required. And if we feel if somebody's feel that okay, they are overly discussing or it is not relevant, you can drop from the call. So people who are interested, they stay in the call, and people who feel like yeah, it's not relevant that much or it is not required for me at this stage, so you can please drop a call. So nothing like that. So we will stick to the topic or the agenda what we are supposed to cover, right? Then we will have a discussion on other things whatever we are. But whatever what are the question answers which you are having, right? Yeah, that we have to address. That we will address, and once we address that, like then we'll move forward with our topic, right? And if we want to discuss any other thing apart from what we are discussing, right, then we'll have that after our session completes, right? So what I will do, once our session completes, I will keep it for a question answers session, right? And what we can do is that actually like we'll have a discussion. We'll also include in that recording only. So it's not like that we will stop the recording. So because some of them have asked that like whatever we discussed on the question answers, better that also come along with the recording. So that is a good thing only because some people want to understand what are the questions which was asked by the other participant, right? So what is the answer for that? So he might need all such things. So we will stick to that. We'll have a recording. But apart from that, if there are no more questions, then if we want to do some other chit chat on other topics, right, then we will stop the recording. Okay. So that we will decide it at the end whether you have to go ahead with the recording or not. Clear? So we'll stick to the agenda in a day-to-day agenda, and then we will proceed with our all our topics. But to be very precise, like when we start with the DevOps tools, whatever tools are there, right? Then whatever we are doing that 1.5 hour, no, that is sufficient for us. Afterwards, like we will not have any questions or anything to be chit chatted on it because all these tools are pretty straightforward. So whatever the concept or the knowledge what it has, right, that same thing I'm going to explain it. So you have to learn the same way, the way I'm teaching about each and every tool. So maybe if you have worked on that tool already, and if you have some questions, yeah, definitely that any question can be asked. But whatever the ongoing session is going on, right, like that you try to concentrate. And if you are having any concern, or if you're not able to understand whatever has been taught on that day, please interrupt and ask me in between, or even at the end also you can ask it, right? Sometime I've observed that some people ask, Rajesh, could you please repeat it? So that's a good thing actually. Why? Because, right, you are not really you have not understood a concept. It is better to interrupt me and ask me for the repetition. So that is always good, and it is always welcome. So I'll be more happy to explain other different ways also. So please interrupt me and keep asking questions. And also we will make it more interactive also, because I know many of you are started asking questions, and like you are learning, you're keen to learn or understand many things. But so that's a good thing. We'll have a class, but it should be more interactive class, right? I'll be speaking more anyhow, but even you can also start asking questions in between, and we'll have some healthy discussion on everyday's class. Clear? So with that, like, we will proceed further today. So what we are going to do today, we are going to learn about, we'll continue with the commands and everything. And before that, what we will do, that we will try to understand, there are other file types of files are there. Say, for example, you have a pipe file. Pipe file is actually, we call it as a named pipe, we say. Pipe file. And pipe file basically used for having a intercommunication between two different processes. So what it means, that suppose you are having two processes, say for example, process A and process B. You have two processes like this, process A and process B. So process A and process B, if these two processes, it want to communicate each other. So one of the method of communicating each other is with the help of a pipes. In Linux, we say piped are nothing but it is a named pipe, right? And right, it's a name pipe, and pipe itself is a buffer. We say it's a memory buffer of a size 4096 bytes. Now it is more than that, right? And pipes are created in memory. So it means that whenever you want to create a pipe file, right? Whenever you want to create a pipe file, then we use a command, the mkfifo command. Mkfifo, and specify the file name, whatever the file name you give. FIFO, and just say something like a test one or any name. Like in my case, I gave yesterday my FIFO something. Then it will create a file with that name, right? So now when you try to run it, okay, I think I have to log into this machine. So this is the Linux server we have. So it's up and it's the same server. I have not terminated it, guys. So I'm just stopping it and again starting every day because I need this server. And if I go to the downloads, and you know that you are having put.exe. Now what happened every day, what you do, right? Like basically, whenever you know that this is a Linux server, and for that Linux server, we have this new key.ppk file. So this is the ppk file which is used for logging in. So the username is Ubuntu. So you know that you have to always give the name Ubuntu. Now what you will do, that you will launch the putty. Every day what you do, what you do, guys. So you will go and you will copy the public IP, right? And you will give the public IP, and you already, many of the settings are already been done. Only that coloring you will do some default, and SSH you expand it, auth you expand it. Click onto the credentials and just point to the new key, whatever. So it is already pointing it. I'm just saying that you browse it and you try to point the ppk file, and finally you going to open that session. So this is what you've been doing every day, and you know that once I get this page, you have to log in with the username Ubuntu, and you're able to log in. So this is okay. This is good. We know this process, but what we are doing here, that it is little tedious task, because that you have to give the IP address after launching it, and then you have to give the Ubuntu as username and log into the server. You have to do. So what is happening? It is little bit pain process. What you can do, that you can actually save the session. you can create a session for your. So now what happened, right? A best way to do it, you know very well that for this server, when I log in, Ubuntu is a user name actually, default username. So what you can do in between, instead of that, you can just say Ubuntu at the rate and give the public IP of this, like this, public IP, and then do all the settings, whatever you want. So go to the color, choose the default foreground and expand this auth, expand sorry, SSH, and then auth, go to the credential, and already it is pointing, fine. Any other settings, nothing, just say open. Now you could say that you're able to logging in, right? Because while giving it, you give Ubuntu at the rate, something like this. So while launching it, you give the name Ubuntu at the rate. You know very well that there are many servers are there which are going to create in near future, and that the servers will be Ubuntu servers only. And you know that I have to always log in with the username Ubuntu only. So can we create a session with the same something like Ubuntu at the rate? Can I create a session with the name Ubuntu at the rate? So let me create it actually. So what I will do that, I will have this like this. I will paste over here like this, Ubuntu at the rate. And then like, you know that Rajesh session, is there anything to be set? No, nothing. Logging in, terminal, anything I have to do set? Nothing. Keyboard, nothing. Bell, okay, it's none, should be none. Features, nothing. Windows appearance, so you're given some big number. Appearance, yeah, I have to go and change it like this. Maybe 14 is fine. Bold is okay. I need that 14. Okay, and the coloring, okay, default color set, and the connection, anyhow you have in the credentials you're already pointing. So it means that when you go to the session, what are the default settings say you already did it, and you have did everything for the Ubuntu at the rate. So do the same thing as a save. You have to save that session. So can you see it? Now you have saved the session like Ubuntu at the rate. Now what you have to do that every day you log in, you just do it. You just launch your put.exe. Go here, click on this load. See, now you just go to your AWS account, copy the public IP, come over here and just paste your public IP of the server and just say open. See, you're so whenever you want to, if you have some default settings, so it is always better that you create a session out of it, so that that session will have some default settings like this, right? So whenever you want to do it, just click on this and say load, and then just paste that public IP of that Linux server and then say open, you are able to log in. So it will save our time to do all the settings every time again, right? So this is the best way of doing it actually, right? Okay, good. Now you are logged into the server. So now what I said right here, coming back to the diagram. So whenever any two processes want to communicate each other, they can communicate each other with the help of a FIFO file or a named file, we say, right? So we can create a file with the name mkfifo and then say myfifo, something like that. So what I can do is here is that actually, like, let me create a FIFO. I think I have already a FIFO file by name myfifo, or if it is not there, let me check. So I'll use a sudo and then like mkfifo and give some name myfifo. Enter. Now you can see that a file by name myfifo has been created. This file is nothing but it's a named pipe, you say. It's a FIFO file. It's a named pipe. So you have created a file in a disk and the file name is myfifo. So this is used for doing an inter-process communication, we say. So it means that whenever the process A want to send data, it can send into this pipe file. In my case, it is mkfifo. In my case, it is myfifo. This is the file. So you can send the data into this myfifo file, and on the other end, the process B is there, it can read the data. So in this way, you can actually, whatever the data you have, the process A, it can send or it can write into this FIFO file. Okay. And then in the other end, what are the other processes there? It can read it actually. Right. So this process will write into the file and this process will read. So that's the reason what happened. If these two processes, which are totally different processes, and if they want to communicate each other means what? Exchange of data or communicating. So one process will be sending data, other process will be receiving the data. Similarly, this process B will be sending data and the other process A will be receiving data. So you are doing some kind of an inter-process communication. And one of the method of inter-process communication is FIFO file. And that is not but myfifo in my case, right? So you have many inter-process communication techniques which we use. As I said, I think I said a few days back, like pipe C there, FIFOs, which we are seeing now, which is nothing but the named pipe. Normal pipe we say pipe, but these are nothing but these are unnamed pipe. Unnamed means there is no name for that pipe. Right? So after that, we have something like a message queues. Shared memory. And finally, semaphores. So these are some of the mechanisms which we use in our inter-process communication. It means that whenever you want to do inter-process communication, you can use any of these tools to do it. But right now, what I'm saying that one of the type of file in Linux is a FIFO file. It means that you can create a FIFO file with the help of a command mkfifo, right? So now I created this file. Now what I will do that I need to write something into the file. So whenever you want to write something into the FIFO file, better you be as a root user. So what I will do that I will switch to the root user. So sudo su. So you are switched to the root user. Let me have a duplicate of the same session. Let me duplicate the session. Right? I have duplicated the session. And now what I will do that here also I'll switch to the root user. Right? I'll switch to the root user. So now you know very well that that file mkfifo you have created under /home Ubuntu. So I'll go to cd/home Ubuntu and say ls. Can you see my FIFO? Yes. Even same thing here also. Go here. Go to. I think I was already there at the time. I simply give cd command to come out from that. So you have a my FIFO file. So now what happened? This terminal will write the data into this my FIFO, and this other terminal will read the data. So how to write a data? You have to just say simple echo greater than or echo hello world something greater than specify the file name something my FIFO. So you have written this data into the file by name my FIFO. So echo by using echo you are just written this data into the FIFO. If you can come to the other terminal and just say echo lesser than my FIFO. I think you have to read it right. So echo your turn, and here I can use a cat command. My FIFO. Let me check if cat command doesn't work. Yeah, cat command. So through cat I'm reading the data. So in one terminal you are sending a data to the MyFIFO, and in the other terminal you are reading that data from the MyFIFO. So this is nothing but you are actually communicating totally with the two different processes. One process where it is running in the terminal 1 and the other process is running a terminal 2, right? So whenever you want to communicate each other, you can communicate with the help of a FIFO file. So where we use it, we hardly use it. Actually, there are some scenarios out there where we use this FIFO file, but this file exists. It means that this file is created in Linux, and it is many times it is required also, right? So this is one type of file. What are the other types of file? Now we have, apart from this FIFO file or name pipe, we have something known as a character device file and a block device file. Character device file and block device file, right? So this is a file, character device and the block device file. Yes.
What is the use case that we use that MyFIFO in day-to-day activities?
Yeah, day to day is something like we're using filters, right? Right. For example, this is one of the way, right? For example, if I want to do there's a command with a df command. If I go df-h, it will show you the file system disk usage actually, right? Df command, right? Or else fdisk-l. It will show you the partitions, or it will show you all the partitions, whatever is there in your system. Now, when I try to run a df command -h, now you will say that Rajesh, I want only the first column 1, 2, 3, 4, 5. First column and the fifth column. I need this first and the fifth column. So then you can use df-h pipe symbol. You're using pipe symbol like this. This is the pipe symbol. Okay. Then you can use a command awk command, something like this. Print of $1 first column and the $5 is fifth column. Okay, you're able to print the first column and the fifth column. Like that. Now, what pipe is doing here? So pipe is basically doing an inter-process communication between two different commands. df-h is one command and awk is a second command. So whenever you want to send an output of the first command as an input to the second command, then we have to use pipe. So now what I'm doing here, I will take this, the whole thing. Right. This is the command I'm using, right? And then I'm using this is the pipe symbol like this. Right. This is the this pipe symbol. And this is the second command. Right. Now what happened? Whenever using this pipe, this you are working or this you are executing in a user space. This is a user space and this is the kernel space. You know, right? Now you know the story, user space and kernel space. And kernel space. Whenever you are executing this command like this, what will happen? How the shell interpret? What shell will do that actually? That since in the command line, you're using the special characters, which is the pipe. So your shell understand that a user is using some pipe symbol. This is called as a pipe symbol. What is called? We call this a pipe symbol. Right? We are using pipe symbol. We are using in the command line we are using in the command line this pipe symbol. Now, why we are using this command? Why we are using this pipe in our command line? Many times we will be using these pipes heavily, guys, in our day-to-day activity. We have to use it because we have to filter it out the output, and the way user requires an output, right? He can obtain or he can get that output the way he needs with the help of a pipes. Pipe acts like a filters, we say. That's like a
Rajesh, my question was different. Like, why we are created using my FIFO and file name, right? And we are checking in other process, other
it
terminal.
is just to show you how you are able to do inter-process communication with help of that my FIFO file.
Okay.
My FIFO file, you created it, right? My FIFO file, you created it, right? Here, when you do an ls, you have created this file, right? Sorry, right home, Ubuntu. You created this file, right? You are asking what is the usage of this file?
Yeah.
The
Can
usage
you
of the
take day
file
to
is
day, like where we will be using this my FIFO?
That's what I'm saying. In one command, through one command, you can actually send a data so that the data will be stored in this MyFIFO file. And through other command or through other process, later you can read the data. It is one-way communication. It means that you are writing something and the other process is reading. It's something like a producer and a consumer. Producer and a consumer, right? So it is basically something like, like how I can say something like you're passing a message, right? Say, for example, like in earlier movies and all, right? Like a lot of uh, people used to do gold smuggling and all, right? And what happened, right? Used to have some 5 rupees half of note used to have, right? One half of the note no used to keep, and the other half of the person who received the gold, he used to keep it actually. So what happened when the boat or ship will get into the other place where it get docked into the sea in some location, then he will come and he will get down and he'll say that what is your name, who are you? So what is the signal? So he will say that I have that half note. He will also go open the half note. Both they will join together and they'll see it is matching or not. Or if it is matching, oh, he's a correct person. So deliver that gold to him, this person, right? Something like that. You are doing an interprocess communication, right? Right. So their interprocess communication, in case of that, you're using that 5 rupees half of note. Same thing here, you're using interprocess communication with the help of a file. And that file is something like a MyFIFO file. So that is a pipe file. And we're creating that file with the help of a MKFIFO command. We use many times. See, I have not personally used this command because even in the scripting also I have not used, but in many places this is used actually. But what I'm trying to tell over here that this is the real scenario which we are using in a day-to-day activity. I'm saying this one. So when
Yeah,
you're using
this
this
is
pipe,
I'm agree.
yeah, this pipe, whatever you're using, it will actually create a pipe here like this. So when you're running this command, whenever shell come across with this symbol, shell what knows that, oh, it will try to create a pipe like this in your kernel space. I think you already watched the video, right? Some of the video which I've told already that this is something like a pipe. So this pipe size is 4096 byte. There also, this pipe size is 4096 only. It can accommodate up to 4096 only. And MyFIFO, right? 4096, or now it could be more than that also. But this is nothing but this is what we call it is a buffered. we say it's a buffer memory which is created in the kernel space. So what this is nothing but we call it as a right end of the pipe. Right end of the pipe. And this is nothing but the read end of the pipe. Read end of the pipe. So now what you do, like whenever you're executing that command, whenever you're executing this command, the entire output will be written into this right end of the pipe. It means that the whole data will be coming and it will be sitting here in this pipe like this. The whole output of the df command. Now, once this command get executed, it will be going into it is going to write into the right end of the pipe. And the other command is going to wait for that for some input to be given. So the input for this awk command will be given from the read end of the pipe. So from here, the output will go to the awk command, and awk command will process this whole data, and it will try to appropriately do what it want to do. So awk will try to print the first column and the fifth column. So when you're using this symbol, automatically a pipe will be generated. This is not, but it's a buffer memory, which will be created in your kernel space, and the size will be 406 byte. And this is the pipe which is used for inter-process communication. Simple. Clear? Now, coming here. Yeah. So now the next is the character device block device file. This is very important file, guys. This is important. No matter if you might not understand today, but that is fine. Right? I don't expect that you should understand everything whatever I'm saying now. So, but you have to just understand that this is also one of the type of file in Linux which we can create. So character device file, block device files are very important files. These files are used for communicating with the device drivers. So character device or block device device file, sorry, are used for communication to the device drivers. So you know that device drivers are the softwares which are used to drive the device or communicate to the device, right? And you know that in the kernel, you have something that device management. Within the device management, you will find plenty of drivers which will be there, right? So usually what happened, there are a lot of drivers are there in Linux, and these drivers are categorized into majorly 4 categories. One is a character driver, other is a block driver, and the third type of driver which we call a network driver, and the fourth is not but the miscellaneous driver. So all the drivers are categorized into 4 categories: character driver, device drivers, block device driver, network device drivers, and miscellaneous device drivers. Now, whenever as a user, say assume that he's a user. So again, the same story. We have a user space and you have a kernel space. Here, a user has logged in. Who has logged in? Ubuntu user has logged in. Ubuntu user has logged in. Now, the thing is that actually, whenever the Ubuntu user, he want to communicate with some device, right? Say, for example, he's using keyboard. He's running or he's typing something in the keyboard. So basically what happened in the system level, what happened, right? Here in the kernel space or in the kernel or in the operating system, we have something known as a device driver, right? A device driver in our case is a keyboard driver. The keyboard driver should get called whenever a user is typing something. How this will get called internally? So it get called internally. This driver will get called internally whenever you're using a character device file. So the Ubuntu user, he's using the character device file actually. He's using the character device file. So this is a special type of file which is used. So with the help of this device character device file, this character device file will in turn will communicate with your keyboard driver. Similarly, you have a hard disk, right? HDD hard disk is there. Now, a Ubuntu user will try to write something into disk, or he'll try to write something into the file. It means that you're actually communicating with the hard drive or hard disk, actually. How the hard disk how you are communicating it? Because in your kernel, there is something like a SDA driver is there, hard disk driver is there, SDA driver, hard disk driver is there. The driver will be running that special program or that software will be running. That we call a device driver. Now here what happened, right? How you can actually communicate with your file, or how you can write into the file, because right, actually you will be using file system operation functions or APIs or commands to do that. But internally, what will happen that it will try to call one block device file. Block device file. That block device file will try to communicate with your SDI driver or the hard disk driver. That hard disk driver will in turn communicate with a hard drive to do all of whatever the operation you choose. If suppose if this is a hard drive, hard disk or hard drive we say, so then this SDI driver will communicate to your physical device, which is hard disk actually. So now what I'm trying to tell that whenever user space process or user, it want to communicate with any specific driver which is running in the kernel space, it can only communicate with the help of a special files, which we call as either as a character device file or a block device file, or it could be some other miscellaneous device files. So that's what reason I said that I don't want to get in detail about this because it is not really relevant for us, right, at this point of time, because we don't use much of the devices files are for communicating with the driver and all. But yes, in our real time, we use some of the character device file in our script also. We'll see. We will use it actually. So what are those character device files and all? We will see it in some time now. So now what happened, right? All these device file, all this device file, like character device file or the block device file, it is associated, this character device file or block device, it is associated with major and minor numbers. What is it? We need not to really worry about now. We can just understand that there is a major device files from 0 to 255, and even the minor number is from 0 to 255, something like that. You can understand, right? So your major number will be either from 0 to 255, and the minor number also will be 0 to 5. But of course, this value is greater now because after introducing after 40 after 2 point not 2 yeah after 2.4 2.6 onwards, the major number and minor number have been increased to 4096. So the number have been increased more, and every device file is associated with the major and minor number. Let it be character device file or a block device file. These two types of files will be associated with the major number and a minor number. Now, for example, here you remember that I executed a command tty. You remember? We executed our command now the TT. So what TT will do, guys? TTY command, TTY will show the terminal name. So can you see that? /dev/pt/1. This is the terminal. Okay, fine, good. Now, if you want to, if you take a file onto the /dev/pt/1, then check that it is a special character device file with a major number 136, minor number 1. So Rajesh is saying that under /dev, there is something like a PTS. Under the PTS, there is something like a 1. What is this PTS? Oh, it's a pseudo terminal, I say. Okay. What is this one? Something like this is not but the /PTS/1, right? Oh, it's a terminal number 1. Similarly, if you go over here in the other terminal, and here if you come over and if you execute the TTY command, let's see what output it gives. /dev/PTS/3. Okay, it is giving you the value 3. So this is again a character device file. It's a character. It means that every whenever a user logs in, your user is associated with some terminal. And this terminal is nothing but what is it? This terminal is attached to your shell. It means that your terminal works with the shell itself. So that's as soon as you log in a system, you'll get a default shell that is nothing but the bash shell. Clear? So now if I go to the cd to /dev, because let me get into this directory, let me see what it has. And say ls, oh man, there are so many files are there. What is it if I do a ls-l? Oh, you could see that there are so many. Whenever the first character, if it starts with the C, it's a character device file, right? Whenever it starts with the B, it's a block device file. Can you see? Oh, there are all files are either character device or block device, right? See, block device files. Oh my God, it means that all are character device and block device. Can I display only character device files? Yeah, ls-l, pipe it to. So now I'm using this pipe symbol, cap C. Okay? It will only show you only the character device file. Right? Similarly, I want to display the block device. Same command with the cap B. Cap means begin with the character B. What is this grep command? We will see in some time. Okay, don't worry. But right now, you try to understand the output. So whenever I want to display only the files which are block device file, I'm doing a ls-l, pipe it to grep cap B and say enter. See, it is all, these are block device files. Now, if you watch carefully, right, you could see that this is the permission. Okay, this is the hard link. This is nothing but the user ID, group ID. Can you see this value something 7, 0? Yes, this is the major number 7, minor number 0. Major number 7, minor number 1. Like that, major number 202 is for root, minor number 1. Major number 202, minor number is 0 for this XVDA. So every block device is associated with the major and minor number. Similarly, every character device is also every character device file is also associated with the major and minor number. Can you see the 10 major number 10, minor number 123? Same thing, major number 10, minor number 223. Like that, it has to be. Okay, that's how your kernel will understand what is a device driver with which the user is communicating. It means that what is a device to which the user is communicating, it depends upon that file's major number. If the file's major number is 223 or 10, it understands that actually, yes, the user who is having a major number 10, I don't know whether 10 is there or not, but let me check. Yeah, 10, yeah, 10, minor number something, oh, sorry, this is 4 major minor number 10. So here, 10 is there, right? Or 10 minor, or we'll take some other, this one. Where is the /dev/PTS? So, PTS. Yeah. So you can see 0, 1, 2. This is okay. So major number 136, minor number 0. Major number 136, minor number 1. See? So 0, 1, 2, 3, like PTX. So these are the character device files which we are using for communicating. It means that whenever a user is creating the terminals, this are being given. Clear? Now all this character device file, block device file, which we call it as a special type of file, this special type of file will always be there under the /dev directory. /dev directory is only meant to keep only the special type of file. It could be a character device file or it could be block device file. But majorly, what you can see in the /dev directory, you will only see that actually most of the files are character device files itself. You might get some doubts now. What is this character device or block device? I'm not able to understand this. Where we use this major and minor number, why it is required for us to run? It is not really required. We need not to really break our head. But what I'm trying to tell that there are some 2 to 3 important character device files are there, which we usually use it in our day-to-day activity whenever you're writing a script. Say, for example, ls-l /dev/null. This is what we use many times. /dev 0. See, this is one character device which we use. ls-l/dev we use. See, these are some special character device files which we use in our scripting. Where we use, I will show you later after some time. So guys, did you understood till here whatever I'm saying? Abhishek, any doubts you have? Afzal, Mahesh sir?
Rajesh, where we can use that cap, Rajesh? Can you show any other example regarding to that cap? You have used the cap, no?
No, here cap means begin. Yes.
I haven't a little bit confusion of that cap.
No, nothing like here. Now you could see that if I do ls-l, can you see you have any normal file? Yeah, normal file is a J, but it is dash. Can you grep for all those files which is having begin with hyphen? See, it will show J. If I say touch Alice, Bob, John, all these are normal files. See, it starts the hyphen. It means that if it is a empty or it's nothing, it doesn't have, it's a normal file. So can you print all the files which is normal files? Yeah. Okay. That means begin with what character of this one? Cap D, begin with the D. So it will only display the directories. So which are those directories?
Yes, right? Got it, Rajesh. Thank you. Got it.
Okay. So now, okay, guys. So as I mentioned it, you need not to really break your head much into this. But what you have to understand, okay, there are some special types of files are there, which is number character device and block device files. It is associated with the major and minor number. And the third is important that all these files are placed under the /dev directory. These are the 3 points you have to remember. And there are some special character device files are there like /dev null, /dev full, /dev 0, which we use in our day-to-day activity, even in our scripting also. Even for some of the command lines also we use these options or we use these character device files, right? So not that much need to really understand, but okay, this much is sufficient for us, right? Now, so that is what. And suppose somebody were having some doubts, Rajesh, what you did like that cd to /dev and did like this. What is a /dev? So guys, we have to learn about the file system, which we have not yet learned. We have to learn that. So then you'll understand all these things, whatever I'm saying. Say, for example, whenever you want to learn the file system, so always you have to go with the cd2/. This is not but the slash file system or nothing, but it's a roots file system. It always starts with a slash. And say enter and say ls. You see all these different directories. This is not but these are the different subsystems, or sorry, not sub. These are the subdirectories which all comes under the slash. So you can treat slash. I'm just saying you slash. You can treat it something like your C drive. Now you know the C drive in Windows, right? What is the C drive? C drive is nothing but your primary partition. It means that all your system files, all your drivers, all your important configuration files, even in your all your softwares, what you install, everything will be placed inside the C drive. And the C drive is nothing but what? It is nothing but it's a partition, it's a primary partition where all the system supported files, libraries, even your bootable files, right? Everything will be in the C drive. Same thing like that, you have to understand. Okay, Rajesh, C drive is something it's very important in Windows. What about in Linux? It's a slash partition, we say. And okay, it's a slash partition, or it's a slash actually. So the file system always starts with a slash. Below the file system or below the slash, you could see that these are the different directories you'll have. You have a boot directory, dev, home, etc, proc, run, sys, usr, var. So we have to discuss all these things in our upcoming, maybe today itself I'm going to cover today about this, right? We have to learn all these things. It is very important. Being a Linux or a Unix user, we have to learn about this file system, how it works, and what are the important things which we have to understand through this file system. Also, we have to learn all those things, because every day when you're working, even you are being a DevOps engineer, or even you are being a system admin, you are being some networking, something you're doing networking, any field you might be, you have to know this file system, because you'll be playing around with the Linux system and you'll be doing a lot of configurations, everything through this important files only. Say, for example, you might go and edit some etc, under etc, you might go and edit certain files. You might go and you might view some of your system logs and all through the var directory, right? All your system softwares and everything will get installed under the USR. You have a temp directory, you have proc directory, you have a root, you have a dev directory, you have a home, boot. So you have many important directories are there which we have to learn and understand. It's very important. You say that, Rajesh, I don't know about this. I know everything about Linux command, everything, but I don't know how this file system works. Means it doesn't really look good. You have to have a very good knowledge on file system also. That is a basic stepping stone in Linux. Whenever you want to learn anything on Linux, first stepping stone is to learn the file system. Then only you proceed further in learning anything, commands or scripting and all. That and all is secondary. That will be coming as when you start learning more and more deeper in Linux. But file system is the one which you have to first start with learning. Do you agree with this statement, guys? Whatever I said?
Yes, Rajesh.
Okay, good. Now coming back here, we'll go back here. So okay, this is what it is about the character device and the block device. So let me, I think already I created it, but still let me create it actually. Sudo mknode is a command which we use actually. Okay, my char C is a character device file. 255 is a major number, 10 is a minor number. Can you see? My char has been created. So 255 major number, 10 is a minor number. See, because I've given this value. Same thing, sudo mknode. What is it? My block. You have to give B. 254 major number, minor number is 100. See, when I do LSFNL, can you see? My block 254 major number, 100 is a minor number. So like that, you have to pass this major and minor number whenever you are creating this character device file or a block device file. That is always mandatory. Okay. So don't ask any extra question about this major number. What is major minor number? Because it will take us to a lot of discussing it. We don't want to really discuss all these things now. Is it clear? So you have to just know that, okay, some device files are there which are associated with some major number, minor number. That's all. No other thing. Okay. Okay, guys. Okay. Hold a second. Now, what is the last type of file which you have in Linux? Is a socket file. Okay, and Socket file is basically used for communicate between two different systems or two different processes which are then which are running in a two different machine. Say for example, whenever there are two processes which are running the same machine, and if you want to do inter-process communication between these two different processes which are running in the same machine, then you can use either pipes, FIFOs, message queue, shared memory, or semaphores. So these are the IPC techniques which we can use it. But suppose assume that you are having two different processes which are running at two different machine or two different laptops. How you are communicating between two different processes which are running in two different machines over the network? Then we have to use a socket. So socket, with the help of a socket, you can able to communicate over the network from one machine to the other machine, or between one process to other process which are running in a two different machines over a network. Right. So we always use it heavily, guys, whenever we are trying to, suppose, for example, whenever the application server. So assume that this is an application server, and this is nothing but a database server. Both falls under the same private subnet. So whenever the application server, it want to connect with the database server, it has to connect via with the help of a socket file. Without a socket, both these application servers and database servers, they cannot communicate each other. There has to be a socket file. So who is going to create a socket file? When you are using any kind of a protocol, suppose you are using some API where you are calling when you're using some applications or some API where you are calling some API, some networking protocols, it automatically creates a socket file. Internally, how it does, what are system calls get called, we need not to worry. But suppose assume that you are using some protocol for communicating. Internally, what happens in the system level, in the kernel level, it will create automatically a socket file. And that socket file will be used for communicating to establish a dedicated connection from the one machine to other machine for communication. A socket file should be there actually. Without a socket, two machines where there are two different processes are running, like say for example here in this case application server and database server, these are two different machines which are running in a two different applications or two different softwares which is running in two different servers. You want to communicate each other means there has to be a socket. And in Linux, actually, we use that socket various way. Say, for example, in case of an API in programming, we call the socket API. Socket system call we call to create a socket. In case of a command line, we call an mksock command. But this mksock command is currently deprecated. So this works in Red Hat, but in Ubuntu, this is not working. This command is not working. There could be some alternative way of creating it. I will find and I will let you know. But right now, mksock command is not working. Even there is no package with that mksock command, so that if you can install and create the socket in the Ubuntu. I have not seen that actually, but what I'm saying that this command will definitely work on Red Hat or CentOS. Right? If you execute a command sudo mksock mysock, then it will create a file by name mysock, and mysock is it's a socket file. The socket file where it is used, it is doing a communication with two different processes which are running two different machines, like that you have to say. So clear? So these are the 7 types of files which we have discussed it. Okay. Now, okay, any doubt so far, guys? Mahesh sir, Abhishek, Ankit Reddy, Vinod, Varun? No?
No, Rajesh.
Okay, good. Now, okay, guys. Now, let us, what are the things we'll be learning today? I said, right, we'll be learning more on commands also, right? There are a lot of commands are there, which you have to learn, as well as we have to learn even the editors also. So I'll be to and fro, I'll be, explaining a lot of commands, right? So now, yeah, when it comes to the command, say, for example, we want to display some string to the standard output. It means that whenever I want to like print anything, so how I can print any string, right, to the standard output with the help of an echo command. So I use a command echo something like hello world. If I run this command echo hello world, you know that it is going to print the whole string to the standard output. So the standard output is not but your screen or the monitor, right? So now you say that, okay, Rajesh, because whenever you're running echo command will print into the new line as well as you're getting a prompt in next line. But you say that I don't want to print a new line, I want to print in the same line, then you can use a -n option. Like this, it will print in the same line, and also the cursor will also be pointing to the same line, right? Sometime we need it, we will use that -n option, right? Now, apart from this, there are many other things. Let's say, for example, if I say echo something Red Hat Linux, so we are having these 3 different words. So what is your intent that I want to print these 3 different words in 3 different lines? So if I run this command or if you execute this, it will show the same line. But I want to print these 3 different words in 3 different line. Then you have to use escape characters like /n, new line. You have to use that. So whenever you're using any kind of escape characters like /n, /b, /c, right? Anything, then you have to enable it, you have to use a -e option. Without -e option, the new line character will not work. So whenever you're using any escape characters like /n, /a, /b, like that, then to interpret it along with the echo, you have to pass -e. See, if you're not using -e, what will happen? It will not interpret that /n at all. See, it will not interpret it. But so whenever you want to interpret it, you have to use a -e option. Right? So you're printing these 3 different words in 3 different lines, but you can see that while printing it, it is taking one space, it is additional taking one space. So you can remove that blank space by using /b, and here also /b. So now you could see that it has been aligned. Right? So echo command is very important in our shell script. Also, we use a lot of echo command. We use a lot because we want to print some string to the to the standard port whenever you're running the script actually. So echo is very much important. It's something like a printf, printf API or printf function what we have in C language. Correct? Clear? Okay. So echo is okay, fine. And apart from that, like what else we have? Like we have a cat command. We have already seen that cat command also can display the content of the file. Does the less command or the more command also can display the content of the file? Yes, I think, because if I see the cat of J, so nothing is there. It means that the file doesn't have. I'll open the Alice file and I'll try to write something into it, and I'll say this file. So I can use a cat command to open that file again. So cat will display the content of the file. Right? And you can even do with the less command, more command also. If you say less Alice, that will also display the content of the file. Okay, and you can even use a more Alice. Okay, more Alice. Now, when I'm doing a cat of Alice, it will show me the content. Suppose that I want to print the line numbers also along with the content. I want to even display the line numbers. Then I think I have to use a -n option. It will show the line numbers. Right? Okay, good. Fine. Now, very important is that actually, like whenever you want to, I think, guys, what about the copy command, move command? You all are comfortable with that, right? Do you have to really teach that copy command, move command, rename command, and all? Do you have to really teach, or like you know already? Everyone, like, let me know if you want to. If I want to cover this, I will cover it, because I suspect that you already know. Many of you already know these commands, basics commands. I will teach you some other commands. No, Sanjay, you know about the commands, or do I have to teach you? Or should I cover it? Okay. So can I consider as a no? Means, I mean, I can skip some few commands, right?
Yeah, you can skip it.
Okay. Yeah. So that's what I mean. If suppose somebody doesn't know, yeah, you can take. But it's a simple only. But I'm just saying, if you know already, like I need not to spend a lot of time in explaining something which you already know. Right. So okay, fine. So now I know we'll be doing a lot of command, executing a lot of commands in many of the occasions. Anyhow, we'll be learning there also. But I'm just saying, as a part of covering all the commands, I thought let me cover even all those commands, basic commands also. But okay, I'll cover it. Okay. Now, okay. So cat command is there. Apart from that, what are the other commands are there? Now, very important, guys. One of the very important concept what is there in Linux is nothing but redirection operators. Redirection operators are very important because right now there are some of the redirection operator, like for example, you have greater sign, you have a double greater this side, you have something like a lesser sign, double less than sign, right? These are some of the symbol you have. Apart from that, you have something like a ampersand is also there. We will see it actually where we use that ampersand and all, right? So now, usually what happen in Linux or in Unix, right? So for example, let me open a page. Now, suppose assume that whenever you want to type something right into a file, so which is the device which you use to write or type something into it? What is the standard input device? Standard input device. The standard input is device that on your keyboard, right? Say for example, whenever I want to execute ls command, what I will do, I will be in the terminal. I'll just say ls and say enter. So how you are giving an input of ls command, through which medium or through which way you are giving the ls input with the help of the keyboard. So keyboard will act like a standard input. Okay. After the execution, suppose I have executed the ls command, you got this output of this ls. The ls output you got into the screen itself. Here itself you got. So what is the standard output? Standard output is nothing but your terminal or the screen, right? Is nothing but your standard output. Okay, fine. Assume that instead of ls command, assume that I type some wrong command, ltt or lttt something. It says that command not found. So this is something like an error you got. Now where this error is going, this error is also printing into the same screen or the monitor. So which is nothing but we call this as a standard error. So there are three channels are there. Three data channels are there. What is the three data channels? Standard input, standard input, standard output, and standard error. STD error. So these three, standard input, standard output, and standard error, these are the three data channels we say. What we call this, we call as a three data channels. Usually what happen, the standard output will always be mostly the value, the standard input will always be your keyboard. It will always be your standard input. And the standard output is nothing but your screen or the monitor or your terminal vision. This is the standard output, usually, right? And even if there is any error which comes as a part of executing some wrong command, even that error also will get displayed to the screen or the monitor. The standard error is also screen or the monitor or the terminal. And in Linux, actually, we give the value as 0, 1 for the standard output, and 3, 2 as the standard error. So this is some value given. The system provides some value for this three data channels. So what are the values? Standard input is always 0. Standard input is always 0. Standard output is 1, and the standard error is 2. The value is 2. 0, 1, and 2. Something like for read, write, execute, right? 4, 2, 1. 4 is for read, 2 is for write, and 1 is for execute, like that. Similarly, standard input, standard output, and standard. These are three data channels. The value what it gives is 0, 1, and 2. Now the question comes, Rajesh, where we use this data channels? We use it everywhere, man. In a system itself, whenever you're working on the Linux systems, you deal with a lot of processes, a lot of application you deal with. For every application execution or every process execution, there has to be some kind of a data channels. So how exactly will happen? Say, for example, if I'm executing some command, say, for example, I'm executing something like ls command itself, enter. So ls command will get executed very well. ls command will get loaded and get executed, and you're getting the output. But how it exactly the ls process or the ls command got executed? With help of a process. So now if you go here, assume that when I try to do an ls and say enter, you're actually executing it. you're making that ls command to run or execute it. So as soon as you type ls and say enter, what the system has did, or what your shell, what your bash shell has did, means it has created a process for that. It has created a process for that. So for every execution, as I said earlier, a process will get created in a Linux system. A process will get created, right? A process will get created. This process has many of the information, right? What are the information it has? It has information about what is a text instruction which I want to run, what is a data instruction, what is a block storage segment, what is a heap segment, right? What are the other pending signals which are there in the process? So many information this process will possess. And apart from that, this process also possesses, it also has an information about the, what is it? It also has information about the open file descriptors. What is open file descriptor means? In a very layman term, what you can understand in a layman term, what is open file descriptor means? You can say that how many files the process can open at a time. Yeah, one process, how many files it can open? Earlier it used to be 1024 files, or 1002. It can work on 1024 file descriptors. It can open it. Now I think it has been increased to more than 4096. Okay. Oh, so okay, Rajesh, I understood something. So you're saying that, Rajesh, for whenever a process will get created, whether it can open up to 1024 or 406 files, it can open. Yes, it can open it. Okay, fine. So what is this file descriptor is all about? See, file descriptor is something like through which it is something, it's like a number. It's like an array of 1024. Array, nothing but it's an array of 1024. So suppose assume that, so this file descriptor is number FD. If the FD, it's an array of 1024. So 1024, it's an array of 1024 values like that. So you have something value like this, FD of 0. Next is FD of 1, FD of 2, FD of 3, and so on, like that. Like that, FD of 1024. So it means that, Rajesh, whenever a process is opening a file, does it uses this file descriptor? Yes, it uses this file descriptor. Okay, fine, good. But what the process will do, that process will always reserve this file descriptor 0, 1, and 2 for itself. For what? Because file descriptor 0 is not but the standard input. File descriptor 1 is a standard output, and file descriptor 2 is not but standard. So these three file descriptors will always be fixed. This cannot be allocated for any other things. Every process, the first three descriptors, FD0, FD1, FD2, will be allocated for itself. It cannot make use of those file descriptors for opening or file or for communicating any other files. Yeah, apart from FD2, FD3, FD4, FD5, FD6, up to FD1024 or FD406, whatever the value is the greater value, it can use all those file descriptors. So Rajesh, is this file descriptor is a property of your process? Yes, it is one of the characteristics of the, 0 to 1024 or 10. Yes, right. Now the value has been increased, sir, actually. The value has been increased now. I'm saying 406, I think now. Now, so what I'm trying to tell over here that, guys, now, Rajesh, this standard input, and standard, what you're saying, this you're saying as a 3 data channels. Is this 3 data channels or 3 FDs? Yes. Are data channels, what you're saying, is it equal to FDs? Yes, it is equal to FDs. FD is not but file descriptor. Okay. So how this process is going to get an input through the file descriptor 0. So the file descriptor 0 is keyboard or the file or some input. Okay. The process is processing something and it has to give the output. So it uses the file descriptor 1 to write. So basically, whenever we want to print something in the screen or the monitor, it uses the file descriptor 1. So file descriptor 1 is what? It is not but your standard output. I think I have to use other color, right? FD1 is nothing but your standard output, which is nothing but your screen or the monitor, right? Suppose when a process is processing something, if it found some error, even the error will also come to the screen or the monitor. So for error, which file descriptor it uses? Oh, okay. It uses the file descriptor 2 like this. So this file descriptor 2 is used as a standard error. So these three descriptors are always been fixed for every process. Am I clear on this till here, sir? I will add more points, but till here, are you clear? Did you understood something, whatever I'm saying? Again, one more thing I will tell you, this is not that much important, but what you need to understand, okay, there is something like, there are three data channels are there: standard input, standard output, and standard error. That's all. But how these data channels are associated with, where it is associated with every process. And every process will have an array of 1024 or 4096 of file descriptors. And the file descriptor 0 starts with FD0, FD1, FD2 up to 1024 or 1023, or else it could be even to 4096. Now, out of so many file descriptors, 0, 1, 2 are already fixed. You cannot make use of it, actually. Those are fixed for these three data channels. That is about standard input, standard output, and standard error. That's what I'm giving 0, 1, and 2. Where the value 0, 1, and 2 are coming, because this is file descriptor 0. It is under standard input. File descriptor 1, oh, standard output. File descriptor 2, standard error. Oh, this is fixed always. Am I clear on this? Abhishek, did you understood? Afzal? So where this is used, we will see in some time now. Okay, Rajesh, you were saying something. We understood, okay. Partly we understood, but where is the actual usage? And Rajesh, being a DevOps engineer, will I be interacting with his FDs and all? I'll be doing no, you will not be doing that, because the programmer, right, when he's writing some program, like, he will be using these FDs actually. He'll be referring to those FDs to do some operation, right? So for that, yeah. Say for example, you are, I don't know, like how much you know, like you know about the OLTP, like online transaction processing, right? OLTP is something like when you are trying to use lot of transactions in the banking, right? You do a lot of transaction, and every transaction is a unique transaction, right? So it's a unique message, or it's a unique communication of what you're doing for every transactions, right? Through a banking software. Now what happened, right? You need to use a lot of file descriptors when you're doing these transactions actually. So there, the programmer, what they will do, he will implement either through C or C++. He will be using these FDs heavily actually. He'll be calling first he has to create an FD, use an existing FDs and all. Right? So there they use some fdupe system call, or a dupe system call. They use it, or sometimes they use that fcntl also to allocate, not fcntl, fdupe or dupe2 system call to duplicate the file descriptor. And so it is all programming part, guys. We need not to really worry on that part. Only we have to worry that, okay, whenever we are working with the system, there are three data channels are there: standard output, and standard error. Okay, input is nothing but keyboard, output is nothing but a screen or the monitor. Even error is also screen or the monitor. And the values are 0, 1, and 2. That's all. Clear? So any doubts you have, guys, till here? Afzal, कुछ doubt है क्या भाई? I know for some people you would have not really understood it completely, but just यही समझो, ये 3 data channels है. कहाँ यूज हो रहा है अभी हम बता देंगे थोड़ी देर में. ठीक है. ठीक है. हाँ. Okay. Any other? Anki Reddy?
No, understood.
Yes, you understood completely?
Yeah.
Okay, good. Okay, Gaurav Tiwari ji, Gaurav bhai. Narendra Kumar, did you understood whatever we discussed so far? Whatever we discussed? I'm reaching out randomly because I want to just know your views. That's all. Rajiv, did you understood whatever we discussed so far? Okay, thank you. Thank you. So guys, okay, fine. Thank you. I assume that like you understood, right? Now, so now whenever you are running any command, suppose I'm running any command, I'm executing that command, right? If I say ls will get executed. So ls is getting an input from the keyboard, from the user. I'm giving a user. As a user, I'm giving an input from the keyboard. So keyboard will act as a standard input. So where the output you are getting after ls is executed, it is to the screen or the monitor only. It is not but standard output. If there is any command which the command doesn't exist, it says the command not found. That is a standard error. Even the error also is getting into the screen or the monitor itself, right? So now you say that, Rajesh, I want to, instead of getting an output to the screen or the monitor, can I redirect that output to a file? Yeah. Instead of getting an error to the screen or the monitor, can I redirect that error output to a file? Yes, you can do it. Instead of getting an input from the keyboard, can I get an input from a file itself? Yes, you can get an input from the file. So it means that you have to use some of the redirection operators. So these are the redirection operators. These are the major, these are three, but this is, we call it as a, this is called as a, what is it, here operator, which we are doing, which we use it for some other purpose, but these are the three major things which use: greater than, double greater than, lesser than. So now you will say that, Rajesh, I will try to ls output I will get here into screen or the monitor, but I don't want to get the ls to the screen or output to the screen or the monitor. I have to redirect that to some other file. Then you have to use ls greater than, give some file name, something like my file, or just say file1. Enter. See, you didn't get the output to the screen. The output of the ls was redirected to a file by name file1. See, what the system will do, or the bash shell will do, that it will try to check whether the file exists or not. Okay, the file one doesn't exist. It will create that file, and the output of ls will be redirected to the file one. So can I do a cat of file one now? Yeah, you could see the ls output is there. Same thing, suppose assume that I'm using a date command, redirecting it to, assume that I'm redirecting to the same file one itself. So already we are having this file one. Assume that I'm redirecting to the same file one itself. So it has redirect the output of the date command output. Now when I do a cat of file one, can you see here? It is redirect the output of the date command. But you remember that just now I did an ls redirect to the file one, right? This one, ls redirect to file one. So what this date, when I do a date redirect to the same file, it means that what are the file one had, right? The content, it has overwritten it. So it means that greater than sign, when you're using to the same file which already exists, then it will try to overwrite the existing data. So whatever the file one has the content, right? It will overwrite it, and the new output of this new executed command will be inserted into this file one. That's the reason file one has only the date output, right? It doesn't have that ls output. So whenever you don't want to overwrite it, you have to just append at the end. Then you have to use a double greater than. Say, for example, if executing pwd command, pwd will show the current, present working directory. When I try to do a pwd double greater than, give the same file name, by name file1. Now if you do a cat of file1, see, earlier it had a date command output. Now it has having a pwd output. So whenever you don't want to overwrite it, you have to just append at the end of that file, then you use a double greater than. Double greater than is very important. Always we use double greater than only most of the time, because we don't want to overwrite the existing data in the file, in the same file. You have to just append the data, then use a double greater than. Is it clear, guys? Now, okay, this two is over. Okay. Now, Rajesh, you say that, Rajesh, when I'm executing any command like this, I'm getting an error. There's a command not found. I don't want to get the output to the screen. I want to redirect to a file. So then the same command, guys, you have to set greater than, but this greater than is for the standard output, not for the error. Then you have to just use two greater than and specify file by name error file something. So now you could see that this command not found, this error, it didn't come to the screen. It has redirect to a file by name error file. So when you do ls, can you see error file? Yes, it has created a file. Now when I do a cat of error file, see the output of the, what are the error you got, right? That you will see that it exists in that file. So whenever you want to redirect any kind of an error, if you are getting while executing the command, then you have to use two greater than. Whenever your actual output means proper output, whenever you want to redirect to a file, then just a greater than or double greater than. Error means always you should add that two, right? Two greater than. Why two you are adding, guys? Can you even tell me?
Standard output.
No. What is two?
File
Standard error. Sorry, standard error.
Yes, standard error. Right. So whatever we did, right? See, I'm using this standard. 2 error means standard error. So standard error, whenever you want to redirect to a file, then you have to use a 2 greater than symbol. You have to use it actually. Okay. Now you have, see, you have a standard output which is nothing but the file 1. You have a standard error file by name error file. Now you say that, Rajesh, I want to run this command. Okay, this is getting an output into the error, the output to the screen itself. I want to read it to some other error file, then use 2 greater than something error file error file 1. So if you do a ls, can you see error1? Yes. But you say that, Rajesh, I don't want to redirect to some new file by name error1. I want to redirect the output of this error also to the same file by name file1. I want to redirect the output to the same file. Now, how you are going to do that? So then you have to use a something 2 greater than ampersand 1 like this. So if you are getting any error, that error redirect to the same output file itself. So enter. So what is it? Command output, but why you got the error here? I think you have to use space ampersand 1. No? Okay, no. 2 greater than does
File
anyone
name
remember?
right? File 1 is not required to provide.
Yeah, correct. Error. I'm redirecting. Yeah, the file name correct. What is it? What is it actually? Even I have forgotten.
And I think you can give to
No, not end. Okay, I think I'm doing some mistake here. 2 greater than ampersand. Correct only, guys. I've used so many times. I remember all these things. Something I'm doing a mistake. If there's any error in your output, error should also be read to the output file only. Then you have to use a file 1. Okay. Yeah, you have to use this only. Yes. So you have to tell the file, but you have to use a greater than sign, not the actual output redirecting to the file 1. And if there's any error while executing, even that also redirect to the same output file only. So sometimes we use this 2 greater than ampersand. Why? Because that you want to get both the proper output as well as the error. Both you need to get in the same file. Then you have to use this symbol 2 greater than ampersand 1. Or sometimes you say that, Rajesh, what are the error output I'm getting? That error output, or yeah, that error, what are the actual output you're getting? That actual output also have to redirect to some error file. Then what you will do? Suppose you're having ls. So if I say ls output will come. Now if you do an ls, it's greater than file 1, right? And then like I'll say that 1 greater than ampersand 2. Let's see it will work or not. No, it will not work. So 2 greater than 2 greater than err 2, 1 greater than ampersand of 2. Now we are going to get. See, the output of ls is getting into the error file only. I mean, this is not the real case. I'm just saying that when you want to redirect the actual output to the error file, then use 1 greater than ampersand 2. That's what I meant to say. Right? So now, so we use this greater than, double greater than, actually we use this one, and we use that ampersand 1 and ampersand 2, that one. Apart from that, actually, we can even use a lesser than sign, which is not but the input redirection operator. This is input redirection output operator. Input redirection operator is something like, say for example, I want to count how many number of lines, how many number of words, and how number of characters are there in a file. Or suppose, for example, I want to check how many number of lines, files, and characters are there, right? Then there's a command by name WC. We call it as a word count. What is it? We call it as a word count. So can I run a WC command and say enter? It is asking you input from the user. So I'll give, let me give the input. Hi, how are you? Bye. And then in the next line, you do a control D. So can you see here? It says that what are the input you have given? There are 3 lines are there. 1, 2, 3. There is 3. 5 words are there. 1, 2, 3, 4, 5. And 19 characters, including the spaces. Right? So WC will give you the number of lines, number of words, and number of characters. Now you say that, Rajesh, I want to see the number of lines, number of words, number of characters of etc possibility. Then you can use a WC. WC less than slash etc possibility. See, now WC is getting an input from the etc possibility file. So this, it says that there are 35 lines, 51 words, and totally 1,850 characters, including the spaces also. So this is very important. We always use it. This WC command heavily for a lot of things. So like if you say, Raj, I want to only print a number of words or number of lines, then you would say WC-L lesser than etc possibility. So it will show you the number of lines only. Number of words means you can use the W option. And number of characters, including spaces, -C options. Clear? Okay, good. So WC understood, right? W stands for word count. If you want more information, you have to go with the man WC. That's what I told you, right? It prints the number of lines, number of words, and number of count bytes for each file actually. So we use all these options actually. This is used a lot of time, guys, in the real time when you're working. WC is heavily used. Where it is used, I will give you a lot of scenarios, and I will show you even like where exact it is used, right? So that you will get to know about this. But it is usually for the more important that it always gives a count. It will always give the number of lines of a file. Right. So whenever you want to verify, whenever you want to do some kind of a testing where the file size is getting increased, assume that. So you try to run a WC-L output, right, from that file. And when you try to get that, okay, the number of lines of files are getting increased, it means that it's nothing but some process is happening like that, you will say. So you'll put a condition that if the WC-L is greater than some value, then you say that actually that the process is going on. If that whatever the WC-L, if it is equal to the same line, it means that nothing is happening to the file. Right? And then you can say that, okay, the process is not running. Something like that actually. So you will put some condition on it. So that's what I need, an output of WC-L to verify whether the file size is growing or not. Something like that. So I will show you some few examples later when we are learning scripting, where we'll learn like how to check whether any logs is inserted or not, or in other words, the log values are getting increased or not with the WC command. We will try to verify that. Is it clear, guys? Still here? Okay. Okay, guys. So let us take some small break of 5-10 minutes, and then we'll quickly come up, and we have to. What we are going to do that we are going to understand now, like how to write a simple C program and how to run it and how to compile and run it, as well as how to write a simple shell script, my own shell script or the first shell scripting, and how to run it. Once we do that, then we will try to see something on a V editor, and then like we can stop our sessions, today's session, right? We have not yet covered much, guys. Only few things only we have covered. I thought I will cover many commands, but okay, that's fine. So we will try to see many other commands tomorrow morning, tomorrow evening, right? 4 to 6 again on Sunday also. And Sunday we will probably start our scripting. Sunday and Monday, these 2 days, I need solely for scripting. And on Tuesday, what we'll do that we will conclude a few more things on Linux, and then we'll conclude by Tuesday. So Tuesday will be our last day for Linux. And from Wednesday onwards, like we will continue with something on networking part. What exactly networking is all about? What are the things being a DevOps engineer we have to learn on networking? So those things we will start on Tuesday actually, right? Even we have sed and awk also. Yes, I will cover that also as part of it, as a part of our course. So we'll have 1 hour on sed and 1 hour on awk programming. Is it fine? Is it fine? So let us take one 5 to 10 minutes break. So we will meet up by 10:45, and then we will continue our session.
Rajesh, can you type history? Can you type history command? I'll take a screenshot.
Yeah, I will have to cover all these things actually.
Yeah, yeah.
Okay.
Yeah, Rajesh, yeah, yeah.
Okay. Okay, guys. So any questions you have so far? Okay. Mahesh sir, any questions you have? Guys, you can take a break. Like I'll be there in the front of system, but others can take a break. Let me pause the recording. Okay, so we were discussing about the lesser than sign, right? Which is the input reduction operator, right? Similarly, we have a double lesser than, which is like a here operator. The use case is like pretty different here. What is here operator? What here operator will do that? It'll try to take a complete input from a user at one at every all entire input one time, and then it will process and it will give the output for like that. Say for example, okay, for example, assume that you say that Rajesh, I want to sort a file. Assume that. So I have something like a I already have a file 1. Let me open the file 2, create a file 2. So I'll use a VI command to create a file 2. I will something like something I'll type pine, orange, banana, grape, and something apple. Yeah, these are some 4 to 5 words are there in this file 2. When I run a command, sort command onto the file 2, so can you see it is sorting in a alphabetical order. Apple A, banana B, grape, and then O, and finally P. So it has sorted in a alphabetical order. So sort command is basically used to sort either in alphabetical order or numerical integer value. If you pass any numerical value, it will sort in a ascending order or in a descending order, whichever way you want it. Right? Now, can I use the sort command along with the here operator to do something? Yes. So what I'll do, I'll use the sort command, double less than. So as per your document, I'm using this double less than symbol, which acts like a here operator. What here operator says that here operator used for taking up the maximum input, everything, and finally giving an output like that. So how to use that here operator? I'm just giving an example. Sort double less than and give some delimiter word, something. I will give something like a EOF, something like end of file, something. And then once it is done like this, it is asking you for you to give an input. So same input I will give, something like I'll give orange, and I'll give apple, I will give grape, I'll give pine, and I will give banana. Okay, this much is sufficient. I'm just giving this 5 inputs. Now I want to process it. Now, always whenever you want to end giving the inputs, you want to end it or you want to just stop giving inputs, then at the end you need to insert this EOF or this special character or delimiter character, what I have given here. This could be anything. This could be Rajesh, Raj, or your name, anything. Right? Here I'm just giving EOF, something like that. And say enter and just give this EOF, whatever it is there. Now you could see that it is taking a lot of inputs, everything one time, and it is the sort command is processing and it is giving an output. This is how the here operator is used. So this is used many times in when you are doing automation, guys. Say for example, you have two servers like this. You have two servers like this, server A and server B like this. So what is your requirement is actually that assume that the server A and server B, server A and server B, you have enabled the what you have enabled? You have enabled the passwordless communication. So you have enabled the passwordless communication. What do you mean by passwordless communication? We will see after some time. But right now, understand that whenever the server A it want to log into the server B without the password, it can log in. Aram se. It can log in without asking for the password. Similarly, if the server B want to log into server A without asking any password, Aram se it will try to log in. So how you log in from one server to other server? In Linux, we use a command known as SSH. SSH is a secure command. We call it a secure shell. Through the SSH command, you can log in from one server to other server. Like, so for example, server A can log into server B by using SSH command. Similarly, server B want to log into server A, then it uses SSH command. How, can you show the practicals and all? Like if you ask me, yeah, I will show you, not now, but I will show it later after some time. But you try to understand that SSH is one of the command, or it is the command which used to do a login, remote login from one server to other server. Suppose in case tomorrow you want to do an SSH without asking any password, that we call it as a passwordless authentication, or passwordless, it can able to log in. Now just think hypothetically that these two servers have been enabled with the passwordless communication. Okay, fine. After that, what you have to do? You will say that Rajesh, I have one script here. I have script here, which is in a server A. Now, what is my requirement is that actually I want to log into this server B. I want to log into the server B, run this script here in this server, not here. Any of the script will run in server A, but I want my requirement that this has to run into the server B. Then what you will do that actually simple. When you want to automate it, you have to say SSH > specify the server B's IP address. After that, what you have to do that, you have to run the command. You have to run that /script.sh. And then like you have to, right? You have to, so what you have to do that actually, not sorry. You have to just say SSH and the server B IP address and use a > and then specify some demote was in the EOF. Then after do your SSH, what you want to do? You want to run that script / and specify script name, and then finally you say EOF. So if you're running through this way, right, what will happen that you are remotely logged into the server B and then you are running the script over there. So this is how we use this here operator many times. It could be script, suppose like you want to log into the server, you want to do some file changes and all, and then go to that path, do the changes, come out here, then finally execute the script. You want to do multiple tasks, right? Then being sitting here itself, then we use this here operator. Simple use case. Clear? I have did many times in my previous organization where I worked, right? I have did a lot of using this here operator, right? I have automated many things. So basically it is used in this way only. Yeah, somebody has some question, I think. No? Okay. So that's all about this operator, guys. So it was better that I covered here at this point of time. Okay. Now let us see a simple way of how to write a very simple C program. We will write with just 2 or 3 lines of program and then we'll execute it. Similarly, we'll try to write a simple shell script and try to see how the shell script work. What are the different ways to run the shell script? So with that, we were going to end it today. And tomorrow evening, 4 o'clock, we will start with what is the difference between compiler and interpreter, right? What is the difference between compiler and a shell? We have to continue over there, that discussion. And later we will be discussing about the V editor. Once we complete the V editor, we will continue with execution some more commands. And then we will halt in some place where I will be showcasing some 10, 15, 20 commands I'll execute and I'll showcase it. After that, we will try to get into understanding about what is the shell features all about. That will take me around 10, 15, 20 minutes to cover. And then we will land up writing the scripts actually. I mean that we'll start with how to write the scripts and all that. We will do it on Sunday, or else tomorrow. I think it's not possible. Sunday only we'll be landing. We'll be learning about how to write a script and all. That 2 hours, right? We will be focusing only on how to write a script and all. And we will see various different scripts, and we'll also see some of the advanced scripts, and I will show you how exactly script works, right? So we will discuss all those things with the syntaxes and everything, so that you'll be able to understand in a better way, right? Now, come back here. So now the question is that, Rajesh, suppose I want to write a program, right? Guys, we have not yet come to the V editor. We will do it. We will be doing it tomorrow. But try to understand. Yesterday, I already told you what is a V editor, and I told some simple method of opening a file and inserting a text in a file and finally saving. Some few things I told you. So today I'll add some more things. But tomorrow we'll have a full-fledged on learning V editors tomorrow. Okay. Now, what I'm trying to do that I want to create one C file. Say, for example, I want to create a file by name hello.c, whatever. So I'll just say I'm creating a new file. I can even use the touch command, touch hello.c, to create a file like this, or else I can even use a vi command, vi hello.c. Now what I will do that I'm writing a C program. That's what I'm giving extension as .c, right? Suppose you're writing a Python script, you will give a .py. If it is a bash shell script, you will give .sh as an extension. If you see the file which is having a .pl, it's a Perl script. .tcl, it's a TCL script. .tk, it's a TK script. So whenever you see some extension, with that extension, you'll be able to understand what type of file it is. So in case of a C, we use a .c. In case of a Java, we use a .java as an extension. So whenever you write any program, C programs on that, there are some of the things which you have to follow. So what are those things? You have to include some standard header files. Standard header files actually. What are the standard? Hash include stdio.h, something. You are including this, some header file like this. Hash include something like std lib.h. Then always the C program starts with the main. So you'll say int main. Okay. Open the bracket. I'll write a simple printf, man. I'll not be doing any big deal. Printf. What you'll do? Just print hello world. We know that this is a simple C program, and return 0. And then finally close with the bracket. Simple C program which we have written now. Okay, it starts the main. Inside a main, you will write some instructions, and finally you will close with the flower bracket. Opening the flower bracket and finally closing it. So this is some 4 5 lines of code which you have written. I will save this file. So once you have opened the file, once you have inserted mode, to save the file, you have to always press the escape and then the shift:/WQ enter exclamation. Right? Shift:/WQ means save and quit the file forcibly. So I can open a file again, hello.c. You can see it. If you don't want to do anything, it's just a shift:/Q. Quit from the file forcibly. Okay, now we got this hello.c. How to compile and how to create an output file. So we use a command known as gcc. GCC. So right now we don't have a GCC compiler. So if I execute a GCC like that, it says a command not found, and it asks you to run this command. See, sudo apt install GCC. Okay, I will run that command. Before that, shall I update the package? Always, it is always a best practice. Whenever you're working on Ubuntu, you should always use the sudo apt update. It will update your apt repository, apt repository. Okay, it has did it. Now you do a sudo apt install gcc -y. So it is installing the GCC package and many other dependent package also it is installed. There are many other dependencies are there, which also it is installed. So it has completed it now. Now what you will do that you want to compile the program, you will just say GCC and then say hello.c. So can you see here? This command has executed successfully. After the command is executed, if you do an ls, can you see a file by name a.out, which we call it as an assembler output. A.out means assembler output. Or this is not, but this is not, but your ELF file format, executable and linking format. We say ELF file format. So basically, you got a executable file. It is same thing like in Windows we have a .exe, right? .exe, it's an executable. You can go and double click on it. Same thing in Linux. It is .a.out. So this is a default file with which you will always get the name as a.out whenever you compile any C program. So how to execute it? /a.out. This is the way to run the program. Right now, what the compiler has did here that I'm using a GCC command. This is a command to and given input of hello.c to compile this. So once it compiles it, you got a a.out file actually. You got a a.out file. This is assembler output, or this is the ELF format file. So this is basically an executable. You got an executable file now after compiling. But now how GCC has converted a hello.c to the a.out? It has did many processes. There are several stages are there, right? We first say pre-processing. That's the first stage of compiling. And the second stage of the compiling is actual compiling. And the third is that about linking. So linking with all standard libraries. So these are the three steps what GCC does, the GCC compiler does. What GCC compiler does? Compiler does. Whenever you say GCC hello.c, what in turn it does? It does three stages. What is that? Pre-processing, then compiling, and finally linking with standard library. Once the GCC does all these three steps successfully, then only it will create a file by name a.out. If any one of the stage will get failed, it will not create the a.out file. Now, what is the compiler basically? See, whenever you write any program in any higher level language, say for example C, C++, Java, these are very high level languages. Now, whenever you want to write any program in high level language, to make it to run, to make that program to run in your system, okay, it has to be converted to the binaries, or it has to be converted to the machine understandable language, we say. And how it can be converted from the high level to the machine understanding language, you can convert with the help of a compilers. So GCC, what it does that it will try to compile the high level language like C, it will compile and it will give you the assembly output or assembler output, it will give output file, it will give. Or now we call it as the ELF file format, it gives it. So ELF file format or assembler output file, these are executable files. Executable file. You will get an executable file. And the default name is always a.out. Whenever you compile any file, always it will give the output as a.out only. Now, what you have to understand at this point of time is that actually, okay, some program is written in C, C++, Java. I need to call some compiler to compile it, and finally I'll get an executable file. And then I can run with the help of a / and specify the exe, it will run it, or specify /a.out, it will run it. So it means that it is taking this whole C program, whatever the hello.c is written, right? You have written, it processes this whole file. It understands, okay, what user has written into this file, what I need to do to compile the program, right? And also it has to see if there is any syntax error is there, check is there, some issue is there when he has written a program. Everything it does some lexical analyzer, synthetic analyzer, it will do everything. The GCC compiler. Finally, it will convert into a executable format or ELF format, we say. So what the compiler will do, you have to say that the compiler will take the whole high level language program like C, C++ or Java or any language, high level language. It will take the whole code of that file, content of that file, and it will compile it, and finally it will process it, and it will give you the assembler output or a.out. This is what the compiler does. So if somebody asks you, okay, suppose somebody is asking for the J Prakash, okay, Jay, if suppose there is any error in the file, compiler will catch that error. It will catch that error and it will not proceed further at all. So it will read the whole code. While processing, it checks whether there's any error or not. If there is an error while compiling, it will stop there itself and will give an error also. Okay, line number this so and so, this error is there. So it will not proceed further at all. It will stop the compiling phase itself if there is any error in the syntaxes. If there is any error in the syntax, right? See, for example, simple. If I go over here and if I open a file, vi, what is that file? Hello.c. Now assume that actually, like I forget to insert this quote, closing quote. Right now, I will see GCC hello.c. See, it will throw error, missing terminator. See, in the line number 6 and on 17th position, something is missing there. Actually, it is giving an error there. So compiler will always give a, it will always process the whole file and it will give an error too. Am I clear on this, sir? Till here, there are many things are there to be discussed. I'm just telling in a very high level. Is it okay? Anurag, did you understood? So, okay. So it does a pre-processing, compiling, and error. Now, pre-process is something like you can just Rajesh first hello.c it will take. While pre-processing, you will get the file with the name something like hello.i. That hello.i will be given to the compiler, and that compiler will take the hello.i as an input. It will compile it, and you will get a hello.o. Hello.o you'll get. And what the hello.o will do, hello.o will be linked with all the standard libraries. Hello.o will be linked with the libraries, standard libraries. You and with the linkers, you to get the final file with the name a.o. This is what it happens internally. First pre-processing, comparing, finally linking. So after linking only, you will get a file by name a.out. Assemble. You can decode that this also, like for example, you can run what is a.out is there, right? A.out is there, right? A.out is there. You can run an nm command onto the a.out. See, it will show you what exactly that output has, some output file you have. Or else there's one more command is a readelf -s a.out. See, it will show you all the things, whatever that executable file a.out file has. Right? So that's all, guys. Actually, about this. Whenever you write, it's the same question. The same thing applicable to any other high-level language like C, C++, or even Java or .NET. Anyway, any high-level language program, it has to be compiled. Why I'm saying because that then you'll ask the question like, what exactly the shell will do? If compiler is fine, we understood it. What about the shell? Shell will act like an interpreter, we say. So what shell will do? Shell is going to execute a script which is already been compiled. It has already been compiled, we say. Right? Shell will not do any compiling at all. Shell will only interpret the script. How it will interpret means it will interpret line by line by executing that the program, what is the line by line, right? And then like what happened, it'll try to interpret and it'll try to execute the already compiled program. It'll execute. So suppose if I want to write any script where I'm using a lot of commands, ls command, date command, who command, so many commands I'm using inside a script itself. Yeah. Now the shell script will execute because all those ls date are already been compiled program. So shell will never do a compiling. Shell will only interpret. It'll execute the script line by line from the top to the bottom. And if there is any error, it'll stop the execution there itself. Right? So in the interview, they ask you the difference between what is a compiler and an interpreter. So it says an interpreter is nothing but the shell only. Bash is an interpreter. Okay, fine. But what the compiler does and what the interpreter does, can you tell me the difference? So to say that, sir, always compiler will do compiling any program which is written high-level language to the assembly language or to the machine understandable language. Whereas shell or an interpreter, it is going to execute your script line by line from top to the bottom. It is going to execute the already binary compiled program. Already binary compiled program only the shell will execute it. Shell will never do any kind of a compiling. It doesn't do. Whereas a Python Python, what it will do, it will first compile the program and then like it will try to convert into the convert into the what do you call now? I've forgotten what is it? Convert into the not byte format. It will convert into something and then it will run it. It does both the things at a time. So it will first compile the Python will first compile it and then execute or run the program. Okay. Clear, guys? So I hope that you have understood it. We will stop it now. So tomorrow morning we will, tomorrow evening we'll see how to write a very simple shell, how to run that script and all, and then we will proceed with commands execution. Also, we will try to understand about like shell features and all, so that we will be trying to cover up tomorrow some more things actually. Okay. I thought I will take morning and evening, so that 1.5 hour morning, 1.5 hour evening, but it'll be too much for you. So that's what I thought that I will keep it for only 2 hours. If you want, like I can even take on Sunday morning and Sunday evening. Sunday morning, 1.5 hour. Sunday as usual, 4 to 6. If you give me like that much time, yeah, happily I can cover many things. But let us see tomorrow. Let's all join at 4 to 6 tomorrow. After that, we will decide if we are okay with Sunday morning. I will take Sunday morning also, 1 or 2 hours. Just come for 1 hour and evening for 2 hours. So that we'll be covering many other things. Scripting, we will try to cover as much as possible in this weekend. And also, I would suggest you all that please go through my channel and read. There are 21 videos are there only on shell scripting only. So go and read it. You'll get to know many things. Actually. Okay, guys. So any questions you have? Anything in today's session? No? Okay, guys. If there are no questions, then we'll stop the session. So let me stop the recording.